Particulate relativity. This is similar to general relativity because it's about gravity, but it's different in that one of the fruits of this research is a new time constant, 5 nanoseconds, which is related to the volume of a proton. General relativity did not discuss particles. So that's why this particulate relativity is appropriate in 2019. See, back in 1919, the proton was just getting discovered and named. So that's years after Einstein gave his general theory. So with this 5 nanoseconds, this allows us to establish things related to atoms and Planck's constant because they also use the proton. The volume of the proton in 5 nanoseconds is related to how Planck's constant affects atoms, orbitals, bonds, and shells. Now, the theory of particulate relativity has another part where I am rejecting quarks, and in place of that, I'm using the mirror at the center of every proton. And in this situation, the gravity 4 dimensions goes into the proton, and the mirror reflects out to the 4 dimensions of electromagnetism and neutron lifetime. So 1 dimension of the 4 feeds the neutron. It's a length. Now the other 2 length dimensions feed the electron from the proton. So this is similar to gravity, where the electron is having 2 dimensions go into it, and 1 dimension that's time-like goes out of the electron. So this is also going to be summarized at the end of this speech today. I'm going to show you a text of a new book I'm producing, and the table of contents and the glossary will be shown. And I'll talk about that next. The Particulate Theory of Relativity is a title of a book I'm writing. So here is the table of contents and some notes that I'm going to share with you quickly. I'm going to just go through it very quickly, and at the end I'm going to feature this thing here, the gravity volume theory, where it says that the volume of a star's baryons in 5 nanoseconds equals the volume of a fallen shell in 1 second. So it's an experiment anyone can do, dropping a rock for 1 second, and the fallen shell is the volume of the height fallen, like 4.9 meters, multiplied by the area of the Earth. And I'll explain that later on, but quickly now we're just going to page through a lot of these things, and then you can look at them later just using the pause button. Now this theory does not cover everything. This is more of a theory of enough. So it doesn't cover black holes or antimatter or decay rates of isotopes. It doesn't use the square root of -1 or group theory like SU of 2. And quantum chromodynamics is thrown out and replaced by the mirror in the proton. And I have references over time from Mr. Christian, and there's also something about the river of space and various things. And I have a glossary that will be explaining how the new scientific concepts are briefly described. All right, so let's go to the final part of this presentation, where I talk about the gravity volume theory. And that says the volume on the left in some time constant is equal to volume on the right in 1 second. So n is the number of protons and neutrons in the Earth, for example. V is the volume of a proton, and tau is about 5 nanoseconds. A is the area of the Earth, and Z is the height fallen if you drop a rock for 1 second. Now, this can be calculated in this page here, showing it's true that the volume of all the protons and neutrons in the Earth divided by 5 nanoseconds is equal to the height fallen by a rock in 1 second multiplied by the area of the Earth. And here's the numbers that show that that's true. So in this new relativity theory, there's a relativity of velocities. Relative direction of time is going the opposite direction of space into protons. The relative areas of the mass over charge area, and also the relative distances, the radius of a proton compared to the radius for a gravity from one mass to another mass. Thank you very much.